So, have you ever wondered what it really takes to build a network that can just handle anything you throw at it? Well, today we're going to step into the shoes of a network architect. We'll see how they design a VMware solution that isn't just powerful, but also, simple and scalable. Let's get right into it.
Right. This is the million-dollar question, isn't it? I mean, it's one thing to just get a network up and running, but how do you build a foundation that won't just fall apart under pressure? No matter how many sites you add or how much traffic you're blasting through it.
And here's the secret. It's not about cramming in the most features. It's all about making a few really big, correct decisions right at the very beginning. It's kind of like building a house, right? If you get that foundation absolutely perfect, the rest of the structure is going to be rock solid. So, the question is, how do you make those right choices? Well, you need a blueprint. And in the world of NSX networking, that blueprint is what we call a mental model. It's the virtual network fabric. Okay, so think of this as your architectural schematic. It takes the whole super complex virtual network and just breaks it down into these simple, manageable layers. And that right there, that's the key. That's how you create a network that isn't just powerful, but is actually predictable. All right, let's take a look at these layers. You've got the switching layer. Think of this as the basic local roads for your data. Then on top of that, you've got the routing layer. This one's like the traffic cop, directing data exactly where it needs to go between different segments. Then you have the services layer, which adds all the muscle. We're talking firewalls, security features, all that good stuff. And then finally, there's the physical attachment layer. This is literally where the virtual world meets the real world. Okay, so we've got our blueprint. Now it's time to make some choices. And listen, there are two decisions in particular that are going to have a huge impact on your entire design. So first up, are your services going to be centralized or distributed? Think about it like this. A distributed approach is like having a fire station in every single neighborhood. It's fast, it's close. A centralized one, well, that's like having one giant fire station for the whole city. You get a single point of control. And then the second big decision, are you building for just one site or for multiple sites? This choice defines what you're going to share everywhere, like security roles, versus what absolutely has to stay local. Okay. So you've made your big decisions, you're feeling good. But hang on, there's one more thing you have to consider. It's this sort of silent dependency that, if you get it wrong, can literally bring your entire network crashing down. We're talking about the trust model. This is the absolute bedrock of certificates and DNS that lets all your network components talk to each other securely. Now, what happens if this breaks? Let's say a certificate expires. Suddenly, your managers can't prove who they are to each other. They just stop talking. Policies don't get updated, security rules don't get enforced, and the results? It looks exactly like a network outage, even if all the data is still flowing just fine. It's a huge deal. All right, that's enough theory. Let's see how all this stuff actually works in practice. We're going to follow a single packet on its journey through this network we've just designed. So check this out. A packet starts its life at a workload. It travels across that switching layer we talked about, then it gets routed between segments, moves up through the main gateway, and bam! It finally exits onto the physical network. See? This path right here perfectly illustrates those layers we discussed earlier, all working in action. It seems like a simple journey, but it shows you the real power and logic of that virtual network fabric model. Okay, let's put this into practice with a real-world scenario. Imagine you're designing a network for a big e-commerce site. Most of your traffic is what we call east-west. That just means it's zipping back and forth between your web servers, your app servers, and your databases. So how do you design for that? What's the right move? Well, the answer here is to prioritize distributed routing. By keeping the routing decisions as close to the workloads as possible, you avoid sending all that internal traffic on this long, pointless trip all the way up to a centralized edge and then all the way back down. And the result? Way lower latency, and just a simpler, much faster path for all that internal communication. All right, ready for a bigger challenge? Let's talk about designing for multiple sites. Now, it's really tempting to just copy and paste your design from one site to the next, but trust me, that is a recipe for disaster. So what do you actually need to do differently? The absolute crucial thing here is to define your boundaries. You have to be crystal clear about what stays local to each site versus what's shared globally. You have to ask, what's consistent everywhere, like maybe your security policy? And what happens if the link between sites goes down or just gets really slow? A truly resilient multi-site design is all about answering these questions before things go wrong. So we've covered the basics of good design. Now let's talk about what can go wrong. I want to walk through a couple of really common pitfalls you need to avoid because these things can completely undermine your whole structure. Okay, the first mistake sounds simple, but it is by far the most common. And let me just ask you this straight up. Could you, right now, draw on a whiteboard the exact path a packet takes through your network? If the answer is no, you might be in for a world of hurt. And here's exactly why that's so important. If you can't draw the path, you can't troubleshoot it when it inevitably breaks at 2 in the morning. Your network just becomes this mysterious black box, and trying to fix anything turns into a complete and total nightmare. All right, the second major pitfall is ignoring the underlay. In other words, forgetting about the physical network. Look, your shiny new virtual network is only ever going to be as good as the physical hardware and cables it's actually running on. And the consequence of ignoring this is just maddening. A really simple physical problem, like an incorrect MTU setting, the maximum packet size on a switch, can show up looking like some bizarre, super complex virtual problem. You'll literally spend hours, maybe days, chasing ghosts in your overlay, when the real problem was in the hardware all along. So after all that, what's the big takeaway? We've looked at the blueprint, the big decisions, the common pitfalls. Really, it all boils down to one simple thing. You've got to think like an architect. So what does that mean? Well, an architect's mindset is all about focusing on predictable traffic paths. It's about ensuring you have clear enforcement points for all your policies. It means prioritizing operational simplicity over just adding more and more complex features. And it's about standardizing your patterns so you have consistency across the whole fleet. Frankly, that's what separates a merely good network from a truly great one. Because at the end of the day, a great design isn't judged by its long list of features. A great network is kind of like a great car. It's not about all the bells and whistles. It's about how reliably and predictably it gets you where you need to go, every single time you turn the key. So I want to leave you with this question. The next time you're designing a network, ask yourself, is your design built for simplicity and predictability, or is it built for future chaos? Are you creating something elegant, or are you accidentally building a monster that's going to come back and haunt you down the road? The choice, ultimately, is yours. Thanks for watching.